The search for alien life has always been one of the things that has intrigued man the most. Are we alone in this universe surrounded by darkness, or is there some other life form that could be present hundreds of light years away? A huge step could have been made by recent news on the presence of biologic molecules in the atmosphere found on a planet more than 110 light years away. Welcome to Brain Craze. In this video we try to understand if we really have finally found traces of alien life. A molecule discovered in the atmosphere of the exoplanet K2-18b 120 light-years away from Earth is sparking a lot of curiosity because in theory it would be linked to the presence of life. Let's proceed step by step. This exoplanet, located in the constellation of Leo, had been analyzed in the past by the Hubble telescope, collecting interesting clues about the gaseous blanket that surrounds it. But what is an exoplanet? To understand what an exoplanet is, we need to start from the star system and identify an area called the habitable zone. The habitable zone is the region around a star where it is theoretically possible for a planet to maintain liquid water on its surface. The concept is based on the conditions favorable for life as we know it on Earth, where liquid water is essential for all known life forms. Therefore, planets capable of having liquid water on the surface are considered among the most favorable for hosting extraterrestrial life. So an exoplanet is basically a planet that is in the habitable zone, so it has the ability to have liquid water on its surface. Since the 1990s, thousands of experiments with different techniques have been discovered. However, this aspect is not sufficient to confirm the presence of life, as many planets discovered in the habitable zone present extreme conditions for life. Suffice it to say that Venus and Mars are also found in the habitable zone of our solar system, but as we know they are not at all suitable for life. Discovered in 2015, K2-18b is a rocky planet orbiting a red dwarf star named K2-18. This planet was discovered using the transit method, which involves observing the planet as it passes directly in front of the host star, causing a small dip in the brightness of the star. K2-18b rotates its star at a distance of 0.143 astronomical units. This is pretty close to the host star, considering that the distance between our Earth and Sun is 1 astronomical unit. It's almost the half distance between Mercury and the Sun. Considering the little distance, the planet is tidal locked, meaning the one side of the planet is always illuminated and the other side remains in the darkness. Once NASA ESA's most powerful James Webb Telescope arrived, its infrared eye was once again aimed at the celestial body with a radius 2.6 times that of the Earth and positioned in the so-called habitable zone, i.e. at the distance at which water can remain in a liquid state. Thus the James Webb found confirmation in the atmosphere of the presence of methane and carbon dioxide, but also, albeit in smaller quantities, of the dimethyl sulfide molecule, as reported in the journal The Astrophysical Journal by the British astronomer Niku Madhusudan of the University of Cambridge, who led the research. The abundance of methane and carbon dioxide and the lack of ammonia support the hypothesis that a liquid water ocean may exist beneath a hydrogen-rich atmosphere as detected on K2-18b. But what is most intriguing is the indication of the presence of dimethyl sulfide, because on Earth it is produced only by biological organisms, therefore by life forms, and it is found in our atmosphere because it is emitted by phytoplankton in marine environments. But is exactly dimethyl sulfide? Let me explain very briefly. Dimethyl sulfide (DMS) or methylthiomethane is an organosulfur compound with the formula CH3,2S. The simplest thioether, it is a flammable liquid that boils at 37 degrees Celsius (99 degrees Fahrenheit) and has a characteristic disagreeable odor. It is a component of the smell produced from cooking of certain vegetables, notably maize, cabbage, beetroot, and seafoods. It is also an indication of bacterial contamination in malt production and brewing. It is a breakdown product of dimethylsulfonneopropionate (DMSP) and is also produced by the bacterial metabolism of methanethiol. DMS originates primarily from dimethyl sulfonneopropionate, a major secondary metabolite in some marine algae. DMS is the most abundant biological sulfur compound emitted to the atmosphere. Emission occurs over the oceans by phytoplankton. DMS is also produced naturally by bacterial transformation of dimethyl sulfoxide (DMSO) waste that is disposed of into sewers, where it can cause environmental odor problems. Webb's next observations should be able to confirm whether this molecule is indeed present in the atmosphere of K2-18b at significant levels, comments Madhusudan. Now the research will continue, and in a year we will be able to have more precise results. In 2020, another molecule had aroused the interest of those looking for life beyond Earth. It was detected in the atmosphere of Venus. At the time it was phosphine, and discussions that lasted many months eventually led to the cancellation of the hypothesis. With the Webb telescope, the group of British researchers are focusing their attention on a type of planet called sub-Neptune, such as K2-18b, because they have a size that is halfway between Earth and Neptune. And among the exoplanets discovered so far in the galaxy, they are the ones present in the greatest number. K2-18b is expected to have a large high-pressure ice mantle inside, a thinner hydrogen-rich atmosphere, and an ocean surface. But of course what is most intriguing now is the possible existence of the dimethyl sulfide molecule, and only time will confirm or deny it. That's all for today. Thank you for watching this video. Don't forget to like and subscribe. See you in the next videos.